In this session, I'll be talking about demonstrating and quantifying improvements through a Lean Six Sigma project. In this session, I'll be describing the techniques for various types of situations relative to measurements. We'll be demonstrating how you can quantify the improvements that was accomplished through the execution of improvement projects. This is where I'm at in the overall roadmap. Now what I'll do is I'll talk about example one. So if we look at example one, we're going to be talking about creation of an individuals chart and then looking at a situation where we don't have a specification. So in this case, we have daily infrequent subgrouping sampling, where we had one daily random sample was chosen, then evaluated. Our incoming call wait time that we had is shown here. We don't really have a specification, so we reported out the median and 80% frequency of occurrence. In this case, there's bounded by 0, so it required a log transformation. So it's a stable process. So we decided we want to improve this overall process. So we wanted to then have in our report out summarize the work that we did. And in this case here, we did a DOE. We described the improvements to the process, added lunch coverage, and so on. Then we wanted to have a control plan for making sure we didn't have a problem later down the road, or things might go back to where they were before. So this is the chart that shows a staging of when we actually made improvements in what we did to reduce the amount of wait time in the call center. As you can see, the numbers went down. Now we want to compare that statistically, so we could present as part of our report out something that would look like this. So now you're given a visual and a statistical assessment of what benefits that you actually have done through the project. You could also look at the variances that you had here, and that how the variances went down because of what you did. You could also go in and show the cost of doing nothing differently, and so the value of this overall project, and you could put it in a spreadsheet when you're calculating, so then any assumptions that you make could be changed if somebody disagrees with you or like to see it using a different value for a particular assumption. Let's look at example 2. So now we're going to have a subgrouping situation. We're going to have the mean and standard deviation. And then in this particular case, we determine the best estimate when we have a specification. So for this situation, we have 10 samples are evaluated daily. Could be a transactional situation, or it might be a dimension on a part. And we have, in this case, we have maybe 10 operators, and we have a, say, random sample from each one of them. This is what our chart would look like here that we have created. We've got some of the stable process. The probability plots indicates that we probably got a bimodal distribution, but notice we took also a log of the standard deviation, since the standard deviation is bounded by 0. We then went in and noticed since we did have that curve, we then looked at the various operators we had. So it looks like operator 2 has got a very much larger value than the other operators, and operator 9 and 10 are also seem to be larger than the other ones. So if we went and did analysis of means, we verify what we've experienced there, where operator 10 really has a lot higher number, and that operator 8 and 9 have also higher values than the other than the overall average. So keep in mind on this particular chart, we've got 9 basically hypothesis tests, and we're evaluating those, and the red lines represent the value at alpha is equal to 0.05 as shown in the top of the chart. So this is describing what you actually did. You maybe compared or looked at what the other operators were doing, 8, 9, and 10 in particular, and then maybe you could go in and make the process so these other operators that didn't perform as well as the other operators would actually go in and make an improvement on their process. So because of this work now, we went in and noticed that we had a staging, and now we noticed in the lower left-hand corner all the operators seem to be performing consistent with what we want, and now the non-conformance rate is real low. And we could also state the financial benefit maybe associated with this. So we want to compare statistically and graphically the two different situations, and this is how we do it, and we can report it out. And so we got a confidence interval, even the estimated difference on the mean, and a 95% confidence interval. Could also look at the variance, and in this particular case we saw a difference in the variances also. So let's look at the third and final situation, where now we're going to be looking at an attribute scenario. In this case here, we're going to look at the value where the center line represents the capability. So in this case, we're looking at, we're looking at maybe things weekly, and we're looking at the number of non-conformances divided by the number of transactions you had for that week. So this is what we came away with. Now, for this situation, we don't have a probability plot. If the subgroup sizes are the same or about the same, the center line is an estimate of the capability process. So we basically say we got a stable process, we got about a 2% non-conformance rate. Again, we don't want people to say, why is this one low and this is high? We want to build hypotheses to go in and give you insight to where you could, what might be driving this non-conformance rate. So if we did a Pareto chart on it, we notice that most of the problems are in setup. So this was what I call the 20,000 foot level. It's a subset of the other higher level view for this particular metric. So in this case here, we've got the number of weekly setup calls within a call center divided by the number of transactions using the call center if a problem were to occur. So this is our 20,000 foot level. So this is focusing just on setup. So now this is where our project is focusing on. Describe our improvements that we made. We want to look at value chain to ensure the process metrics are maintained on an ongoing basis when we get done within our control plan. So what we've done here, we made some differences into our process, and now it's staged. So we can go in and do a comparison of the failure rate before and afterward. And what we look at is the sample size for all the data from the recent region of stability compared to all the data from the previous before change process stability. So in this particular case, we believe we improved by 0.007, and we got a 95% confidence interval on what we believe the population would be experiencing. So in this session, we talked about demonstration, quantification, improvement for continuous data without a specification, continuous data with a specification, and there are multiple samples per subgroup, and also how you could do the same sort of analysis with attribute data.